Hey guys, this is Srini and you're watching basic Python tutorials on my channel Python for Microscopists on YouTube. And these videos again are intended for students, researchers, image processing enthusiasts who would like to perform or get started with image processing in Python. So in today's tutorial, we're going to talk about reading images in Python. So how do we load these images into Python so we can perform some image processing operations on these images? Now, there are many ways of reading images into Python because there are different libraries that can actually handle data or 2D and 3D and multidimensional data. So I'm going to talk about 3 or 4 of these libraries and show you how to open images, and I'll also comment on why certain library or what's the primary purpose of a certain library, so you can decide on which library to explore further for certain tools for image processing. So let's get started. Now again, I'm back to my Spider interface that's part of Anaconda distribution. This is a great IDE because it comes pre-packaged with most of the packages I'm going to talk today. And so the primary, I would say the 4 primary libraries in Python that can actually handle image processing, or in fact today let's just focus on loading images or reading images, are something called Pillow. And when you import it, it's PIL, but it's called Pillow. When you install it, I'm going to talk about that in a minute. And the other one is Matplotlib. Okay, this is the second one. And scikit-image is another program. And finally, OpenCV is the 4th one. And in addition to this, there are other libraries out there. For example, if you would like to load proprietary images, especially from a microscopy point of view, if you, for example, are working with CZI image, this is the image format that Zeiss uses. So their microscope images are CZI, and they contain all the metadata that you need to process these images, for example. And that's the reason why they have their proprietary format. Now, there is another format called OME-TIFF, OME-TIFF. And this stands for Open Microscopy Environment TIFF format. So which is nothing but a TIFF file with an embedded XML that has all the information, all the metadata about that specific image. And go ahead and search for OME-TIFF online. And this is in fact by Bioformats. And if you use ImageJ, you know that you can actually load any proprietary image, whether it is from Zeiss, Olympus, Leica, Nikon, whatever microscope you have, or DICOM formats. If you're working with CT scan images, Bioformats actually is this one versatile toolkit, in fact, that can load, that enables you to load any image, any format, and save it into any other format. And their format, their recommended format is OME-TIFF, OME-TIFF. And that's because it doesn't just convert an image into a TIFF file, which is okay. I mean, it does convert that. But when you just convert anything into just an image, you lose all the metadata. What is the pixel size? So 20 pixels mean, is it a satellite image, and does 20 pixel means like 20 kilometers? Or is this a microscope image where 20 pixels is, let's say, 20 microns or something? So pixel size is very important, and that's why OME-TIFF, excuse me, that's where the advantage of OME-TIFF is. So there are other libraries, to handle these images, and I'll talk about that. But let's stick with the basic JPEG image that we are going to work with today. And let's start exploring the first one, which is Pillow, and it's actually called PILLOW, Pillow. And this is it's an image manipulation and processing library. Okay, it enables you to load image, of course, but then it has tools for image manipulation and processing, and meaning you can use Pillow to, for example, crop images, resize images, and do some sort of a basic filtering. But for advanced tasks, let's say you want to do object detection like computer vision, for example, or use machine learning, there are other other packages like scikit-image, OpenCV, scikit-learn. So there are other packages dedicated for that task. But for rudimentary, for basic image handling, image processing, Pillow is an excellent, excellent library. So to install Pillow, you would, if you use Spider IDE, you probably already have it. But if you don't have it, you just do pip install. Let me actually zoom in so you can see it a bit easier. So you just do pip install PILLOW. But when you call it, it is import PIL all in uppercase. So this is how you call it, from PIL, or you can just import the entire library. I'm just going to entire a specific function or a module that I would like to use. So from PIL, I would like to import image with an uppercase I. Okay. So from pil import image, and now I can read an image. So I can just say define a variable called image, img equals to image, the one that we just imported, dot, and within that module there are so many functions, as you can see, bilinear, bicubic, and a whole bunch of these. But within this, I would like to I'd like to use open. I could have just typed it over there. So I can just type open, yeah, image.open, and what image do you want to open? And this is the local file path name. Since, again, I'm working in this folder, I have all my images under images. So let me go ahead and type images slash, and my image is called test_image.jpg, and that's pretty much it. Okay. Now we are reading an image. Now you can actually print the image type. The reason I want to print this is to show you that this is not a numpy array. When you read an image in PIL using PIL image.open, the image is not a numpy array. So doing some sort of a math or something, if you want to use numpy to do to manipulate these images, then you need to convert this into numpy first. Okay, but let's first go ahead and type this. And you see it says class JPEG image plugin and JPEG image file. It does not say numpy. If it is a numpy image, it would have actually said that. Okay, so this is, again, that's a key point to remember. This is not a numpy array when you do PIL image, but that doesn't mean you cannot do image processing. Of course, if you use the functions within Pillow, the modules within Pillow, they can handle this image pretty nicely, and then you can perform a lot of these. And in fact, in one of my next tutorials, I'm going to cover maybe only Pillow, and then just see what can we do, within the Pillow module, within the Pillow library. So now to show an image, like we imported this, you can just do img.show, and when I again run this, it should open. It actually opened a window on my other screen. So let me just go ahead and drag it. And this is the image that that we just loaded, okay, or reading using our image.open. And this is a color image. Now, again, that's a JPEG image. If you just do image.format, it should tell you exactly. Let's go ahead and run this. It should come up with a message saying this is a JPEG format. So let me go ahead and kill this window up there. str object is not callable. So when I do, oh, sorry, this is again, this is my mistake over here. It should be print image.format. So unless you do this every day, it's very difficult to remember all of this. But let me go ahead and comment image.show. I don't want to show the image. I just want to run. And this is a JPEG image, as you see here. It says JPEG right there. I do not know an easy way of zooming into this screen on the right-hand side. So I'll be digitally zooming in later on to show the result on the right side. So we know that this is a JPEG image, and that's pretty much it. I mean, that's how you import an image using Pillow. But since we mentioned that this is not a NumPy array, let me go ahead and show you how to convert this. So let me write a new image called image1. All you need to do is np.as array, and or we are trying to convert this image into a NP, but it's saying that NP is not defined. That's because we're not calling it. So import numpy as NP. Yeah, so now numpy is available within this program, and np.asArray now makes sense. And go ahead and actually type the type of image1, and it should say this is a numpy array. Well, yeah, you see this is a numpy array. So this is how you can convert your imported image using Pillow into a numpy array. Now, you don't, I mean, if you know that you're going to work with, numpy arrays and everything else, and if you're not going to do image processing using Pillow itself, then you may as well import your image using a different format, different way that imports your image natively as a numpy array. So the way to do that, again, let's comment so we can separate this. Now the next package, we mentioned Pillow, and now let's look at Matplotlib and the way you write this, Matplotlib. Okay, this is actually not an image processing library. It's a plotting library for Python programming language. So it's and within Matplotlib, there is a very useful plotting library, plotting module that's called pyplot. Yeah, it's called pyplot. So pyplot is it's very commonly used to create 2D plots, to generate the plots and graphs. And it's actually, if you are coming from MATLAB, it looks very similar to MATLAB. I mean, you can generate plots that look very similar to the ones that look like in MATLAB, except obviously this is free. You don't need a license like you do for MATLAB. Now, in addition to just creating these plots and graphs, in 2D, you can also visualize images using the Matplotlib pyplot library. You can visualize images because visualizing images is nothing but plotting in 2D, right? I mean, you're just plotting a bunch of numbers in 2D. So Matplotlib also has, again, a couple of tools to import images. And first of all, if you do not have Matplotlib, by the way, you should if you install the Spider installation part of Anaconda. If not, you can actually pip install this, pip install matplotlib. Okay, pip install Matplotlib. And this is one of the few packages where you use the same name for installing and calling. And this kind of initially frustrated me when I was learning Python. I'm like, okay, I'm installing Pillow, but then you import pill. I'm installing OpenCVPython, but then you import it by calling CV2. I'm sure there is some reason why that happens, but again, if you're a beginner programmer, that can be a bit confusing. So to import Matplotlib, you just import Matplotlib. And let's actually import Matplotlib. But within Matplotlib library, there is a module called image. And yeah, so let's go ahead and import this. But every time it can be a bit difficult for us to type matplotlib.image. So I'm gonna import this as mpimg. Okay. So I'm gonna create an alias, or I'm gonna give it a short name, so I can just type mpimage instead of matplotlib.image every time. Okay. And since we want to visualize the image, let's go ahead and also import pyplot. I could have done everything in one line, but let's just go ahead and do this. Import matplotlib.pyplot as plt. This is pretty common convention. You would see a lot of people use exactly the same terminology, Then I can go ahead and type plt dot something, to use the functions. So now let's actually go ahead and import an image. And again, in this case, my image is imported by using mpimg, which is nothing but matplotlib.image.imread. I could have just imported only imread. And when I put dot, it's showing me everything that I can actually use. And in this case, it is imread. Okay. matplotlib.image.imread. And again, the way I do this is pretty much the same. Let me go ahead and copy this. Let's copy the same image. Let's open the same image. And now that's it. So now my image equals to the image I just read. Now let's actually see if this is what is the type of this image. So if I type image, type, and it should say that this is a numpy array. Now again, I don't want to click the green button because then it runs all the code up here and also this down here. I just want to run these lines. So I'm going to select this. Now I can type F9, or I can actually click this button. So it runs only that part of the code. And you see on the right hand side, it says this is a numpy array by default. So as soon as I import the image, it's imported as a numpy array. Unlike in Pillow, where you have to convert this into a numpy array if you plan on using tools in numpy. So now we know that this is, now you can actually look at, for example, the image size. Yeah, we've done this a couple of times in the previous videos, but let's go ahead and do dot shape, and it's going to tell you the shape. Because again, this is a numpy array, I can go ahead and use this, and it's going to say this is a 513 number of rows, 639 columns, and 3 is the number of such images. Because this is a RGB image, red, green, blue image, we have 3 such images. Now, there's a reason why we imported PLT, right? So we want to show the image. So the way you do that is PLT.show, and now I just need to type IMG. So this actually shows the image, and let me comment these two statements. We understand what they are. So let me go ahead and comment this and run this part of the code here. So now we should see the truth value of an array with more than one element is ambiguous. Use any or all. So let's see why this is actually giving us this this error. This is we already know that this is an numpy array. Again, this is the mistake that I commonly do. It's not plt.show, it's plt.imshow. Okay, plt.show is something else. So let's see if this works again. Yeah, so it's showing the image on the right hand side right here, and you can see the scale here in number of rows. Number of rows is nothing but y-axis, right? I mean, the number of rows should be around 500 something. The last we checked, it was 513, and the number of columns is 639, which is nothing but x dimension. Okay, and this is a color image, so we have 3 different channels. We can split channels and we can do all of that, and I'll cover that in a different tutorial. Right now, let's focus on how to open images using all of these various libraries. The PyPlot itself can be literally a few hours or days of lecture by itself, and I'll let you go and read the documentation for PyPlot. There are so many things you can do. For example, one thing is color bar, I believe, color bar. And when I do this, it actually puts a color bar right next to this image, which can be very useful. Yeah, it's a scale saying that, okay, the brightest green is like 250 pixels or something, and so on. So sometimes these can be very useful. So there are a lot more that you can do with PyPlot, but let's focus for now on just understanding how to open images. So that's Matplotlib. And now the next one we can do OpenCV, but I want to spend a bit more time on OpenCV. So let's go ahead and do scikit. So let me go scroll this up, and now let's go ahead and do scikit image. And scikit image is again a image processing library in Python. And you can use it for image segmentation, for example. You can use it for geometric transformation, color space manipulation. You can do analysis. You can do filtering and feature detection, for example, if you want to extract a whole bunch of features for your machine learning. So scikit image actually has, it's a very good traditional package if you want to do, it's a very good package if you want to do traditional machine learning tasks, such as, for example, if you want to use random forest or support vector machines. And don't worry if you don't know any of that. Most of these are literally a couple of lines of code within scikit-image. So take your time to understand those, and if I have time, I'll eventually cover those topics also. So anyway, so scikit-image naturally has tools to import images. So the way the way you install this is pip install. You should already have it again if you have Spider. Pip install, I believe this is scikit -image, scikit hyphen image, all one. And to import this, you just do sk image. Again, this is one of those that's different, you know, between installation and how you call it. So let me just say from sk image, let's just import a few things. Let's say I want to import IO. Okay, so IO is a way you can actually read the images, and let's import IO, and now I can just say image equals to IO dot. Yeah. Now again, imread is very common, just like we have used imread in Matplotlib. It's pretty much the same function here, imread, and I'm going to go ahead and paste this path in here, and this is exactly how you read an image. And by the way, now you can actually go ahead and do print type of img, or we call it image, so let's keep it that way, and let's run only this part of the code. And unexpected end of file while parsing. Again, I may have made some sort of a mistake here. Print, oh yeah, let's go ahead and run this again, and it should say this is a bit slow, as you can see, and hopefully this should say this is a numpy array, and you see it's a numpy array right there. Okay, so even in, just like in Matplotlib, in scikit-image, by nature, when you import an image, it's converted to a numpy array. And again, you can visualize this these images. So let's actually import this. Exactly the same thing here. Okay, and now let's go ahead and plt.imshow. Maybe it's faster to type, but let's just say image. Okay, so let's go ahead and look at the image, run only these lines, and you should see pretty much exactly the same thing. Okay, so this is scikit-image is just another way of importing an image, but it looks exactly the same as Matplotlib. So you can use either, it doesn't matter, scikit-image or Matplotlib. Now, one thing that probably I'm actually thinking whether we should talk about this. Because we're talking about NumPy, you can actually convert, or while importing, you can import the images as different data types. You can import image as a float, for example, as unsigned integer 8 or something. And these are all functions or modules that are available within scikit-image library. So you can convert those. So first, let's actually look at the format here. So the way we do that is let's go ahead and look at let's actually import IO, and let's import something called image as float. As the name suggests, it converts your image, it imports your image as float, and you can also do image as UBYTE. This is image as unsigned integer over there. So now when you, in fact, let's go ahead and print image, so you can see how the image looks like, and these are all numbers between 0 and 255. So this is these are all unsigned 8-bit. In fact, if I go to Variable Explorer, my image up there, as you can see, is unsigned integer, and these are the dimensions over there. So now let's convert that. Let's actually convert this or import this image as float. So one way to do this is let's say I'm thinking whether we should just do as type np float, because you can actually import np or I can actually convert, let's actually convert this image float equals to, okay, or image as float, img as float, and let's do that, convert our image. Okay, now let's go ahead and print image underscore float. So let's run these lines and see what happens. And now you can see all the numbers are between 0 and 1, and my image underscore float is a floating 64 type. So I can convert this, or I can actually do io.im read, and I can actually also as type dot as type and np.float. So what this does pretty much, I believe this does pretty much the same thing. So if I, instead of image.float, let's comment this out and then print the image itself right here, and let's run these lines. And that's the difference right here. Do you see the difference? So when I do image as np.float, so what you would think is, I mean, intuitively, when we see float, we would think that the numbers are between 0 and 1. And the D type range, is between 0 and 10. But if you use as type to convert to float, the values, they don't lie between 0 and 1. So you need to be a bit careful about this if you plan on doing some sort of a math. I'm glad we went through this exercise because we just realized that, okay, if you use np.float as type, this is using exactly the same number, 92, except instead of an integer, it's just putting a 92 point right next to it. And that is technically a float number, but this is not a float image where the range goes between 0 and 1. So again, just to repeat this, let me delete this. So our image is an integer again. Again, let's go ahead and print this. So we see what the image looks like. So this is nothing but an integer right there, unsigned integer 8. And now when you convert this image into float using image as float, this truly converts all the values. So if you look at 92 here, and let's go ahead and run this. Let's go ahead and run this. Now, I'm printing image again. Let's actually do image underscore float. So let's see what happens to our value 92. So our 92 became 0.360, and I wonder, I believe if that is, let's go ahead and open our calculator. No, actually, why would we have a calculator right here? So let's see if this is 92 divided by 255, because now previously our maximum was 255. And I'm trying to normalize 92 to 255, and that's nothing but 0.36078 something. And that's exactly what we got, 0.36078. Basically, when you convert this to float, it's automatically scaling everything between 0 to 1. So when you do your math, you know that, okay, this is the values are between 0 to 1. So be careful when you import images as type using numpy. Okay, it's probably not what you think is going to happen. So this is how you use scikit image, and we keep injecting numpy in here because that's exactly, I mean, all the tools that we need, for image processing or matrix manipulation, these array manipulation are in numpy. So now let me talk about OpenCV. And again, to install this, let's get to that in a second. But first, OpenCV, it's a library of programming functions that are mainly aimed at computer vision. I'm going a bit slow so we can understand. This is a library of programming functions. It's got all of these functions that are excellent for computer vision. What does that mean? It's very good for images or videos, including live videos. If you want to do facial detection, if you want to do object detection, motion tracking, OCR, which is optical character recognition, automatically reading numbers from somewhere, or letters, from handwritings, or public signs, and it's also good for segmentation and for including artificial neural networks, artificial networks and also deep learning. So OpenCV is, again, it would be an overkill to use OpenCV to do some rudimentary tasks that can be easily performed in, for example, Pillow. There is a lot of overlap between Pillow and, well, some overlap between Pillow and OpenCV in terms of basic image processing, but OpenCV is completely dedicated. Let's say it has all the tools for object recognition and other advanced image processing. So to install this, if you don't have this, you should. Again, if you have Spider, to install this, pip install OpenCV-Python. So this is how you install it, OpenCV-Python. But then when you call it, it's actually just CV2. So you just do import CV2. That's it. Okay. Again, one of those confusing things here. So let's just go ahead and import OpenCV2. Now, because this is dedicated to image processing, there are a lot of functionality even for image reading an image. For example, you can just say image equals to CV2 dot. You can import images as I believe it should be in uppercase. I am read underscore color, and then you can just put whatever the image is, and let's go ahead and copy this image up here and see what happens. Oh, it should be in quotations. So this is our image, and let's go ahead and look at this. So plt.imshow. Okay, so let's use this again. And by the way, we need to from matplotlib dot pyplot from matplotlib import pyplot as plt. There are various ways to do this, but anyway, let's stick with this. And now when I run this, object is not callable. I am read dot color image equals to, and what did it say? Trace back int object is not callable. I am show. So let's actually do it the easy way. Okay, again, I almost never ever use reading an image like cv2.imReadColor. Obviously you can see that I'm not good at this using this this specific way. So of course we can Google search and find the way. Let me go ahead and do the way I normally do it. This is cv2.imRead. Okay, and this is just a regular cv2.imRead, and that's pretty much it. And just go ahead and show this. Okay, so if I run these lines, if I run this, this should, I mean, that's how you can actually look at the image, and the colors are changed. I'll talk about that in a minute, but you can see that we have loaded our image. So this is no different than scikit-image or Matplotlib in reality. But let's say if I put a 0 right next to it, then it's going to be read directly in as a. In fact, if I put 0, it's a gray level image. Okay, it's a gray image. And if I put 1, it is a color image. If I put 1, it is a color image. So let's go ahead and run this. And in fact, it's actually showing things in weird colors and everything, because that's the way, that's the difference in terms of how the images are handled, or between OpenCV and Matplotlib. So instead of using Matplotlib, let's actually use the functions within OpenCV to visualize images. So we can actually visualize the true images. So I can do cv2.imshow. Okay, cv2.imshow, and what do we want to show? Image. Okay, and well, I want to call this, let's say, gray image, for example, and let's actually change the name of this to gray image and change this value to 0, so we can actually see a gray image. And let's go ahead and run this, and hopefully we should see when we do cv2.imshow, it is one thing. Now it's actually, I have a screen here that says not responding. It's actually, you see, now I have to kill this, and it takes a few minutes, and it's the typical stuff that you go through when you deal with cv2.imshow. I did not see the image. What's happening? Whenever you do cv2.imshow, just do cv2.wait key and put some sort of a time. So this is nothing but maintain the output window until, if you put 0, until I kill it. If you put like 1000, for example, that is 1000 milliseconds, which is 1 second. So let's just do cv2.wait key and then cv2.destroy. I think A is uppercase in this case, W is uppercase. If something is wrong here, we'll find out anyway. And this destroys all the windows created. You can actually create multiple windows. This destroys all the windows created. So let's go ahead and run this. And maybe that's a bit confusing. Every time you do cv2.imshow, just go ahead and type these two. That takes care of the issue that we just saw. So now it should actually open an image, and then hopefully it should just stick there. So it's still opening. I realize that on my system the CV2 is a bit slow. Oh, it says by the way, I'm blaming CV2 here, which is a rightful blame. Let me go ahead and kill all the other windows here. It says no attribute wait key, and again for the wait key the K is uppercase here. Always do this mistake. So now third time. Let's hope this works. Third time is a charm. So now, yeah, it's right there. So let me go ahead and drag this window right here. Okay. So cv2.imshow. Now let me go ahead and kill this and put 1000 here. Okay. So this actually leaves the window open for 1000 milliseconds. So let me go ahead and run this, and there you go. It destroys all the windows after 1000 milliseconds. Okay, so it's nothing but, okay, after 1000 milliseconds, what do you want to do? Okay, it destroys all the windows. Previously, when I put 0, it's a manual thing, so I'm intentionally destroying these windows. So I usually put 0 because I want to close it when I want to. Let's go ahead and do cv2.imshow, and instead of, let's just say color image, and let's create an image called color image. Let's copy this, and this would be color image, and change this to 1. So 1 is color, 0 is grayscale, and I believe 2 is don't change anything, just import everything as is, including alpha channel. Okay, so when I run this again, something some mistake somewhere that I've done. Color image equals to undefined name color. Oh, not image, it's img image. Let's go ahead and run this again, and well, two windows here, one for our black and white, one is color image. And again, the name I put in the quotations right there is the name, is the heading for my window right there. It says gray image, it says color image here. Okay, so now I can kill these windows, and this is how you can open this. And by the way, the color image, I should have mentioned this again. Let's go ahead and run this. The color image looks correct this time because my original image looks that way. Okay, but when I used PyPlot, PyPlot to plot this, the color image appears to have inverted the color. So let's go ahead and do this one more time so you can actually see. Let me do my color image, the plot over there, and not show these two. And you see, okay, let's do color underscore image, and run this again. And the image you see has different colors. You know, my green looks different. My other colors look different. So let's look at the original image. So my green is different. Yeah, my blues are now like a yellow, and my reds seem to be in blue here. And there is a reason why this is happening, because by default, CV2 handles images as BGR, blue, green, and red, not RGB, not red, green, and blue. So this is the difference between these two, but you can convert them. I mean, you can actually do, instead of PLT dot imshow color image, you can actually convert this. In fact, I have this command here, so let me go ahead and paste this. plt.imshow cv2.cvt color, and what I'm doing is changing the color space from BGR to RGB. So now when I print this, you should actually see the right color space on the right hand side. You see now the image looks correct. Okay, so if you are using Matplotlib to actually look at your images, then of course you can change the color space. You can change BGR to RGB. You can change the BGR to HSV, hue, saturation, space, and you can change these to other spaces like this. So, so far we looked at 4 different ways: OpenCV, scikit-image, Matplotlib, and Pillow to open these images. But what if you have proprietary images? What if you have images, like I mentioned, that are from a microscope manufacturer? Or what if you have an OME-TIFF image that you want to open? Now you can actually Google search, and it's very easy to find like various libraries to handle these. For example, for CZI files, I did a quick Google search. CZI is again the Carl Zeiss microscope image format. So go ahead and pip install. You probably will not have this even with Spider. So go ahead and pip install CZI file, CZI file. Okay. And now you can just import CZI file, and now I'm going to say my image is equals to CZI file dot, I think it's the same command, imread, because it's pretty common with all the languages. So this is images slash, I think I have a same test underscore image dot CZI. I converted the same image using the Zeiss software and test image.czi, and now if you just do print img dot, for example, shape, you can actually see what the shape of this image is. And let's go ahead and run this, and yep, as you can see, it's actually reading this image, except now instead of just 513, 639, and 3, it's actually putting 1 before this. And CZI files and OME-TIFF files and a whole bunch of other proprietary formats, they can be 5D images. 5D. You have 2D images that are gray. Another dimension is for color. That makes it a 3D. And then you have a true 3D, which is the 3rd dimension, if you have a 3D volume color image. And the 4th dimension can be time. So if you have a color 3D volume that's evolving in time, and if you want to analyze it, then you need these 5 dimensions. So the dimension 1 here is probably the time space right here. And the next one is your rows, columns, and RGB over there. So this is how you handle CZI file. And for the other one I mentioned is OME-TIFF format, which is OME-TIFF. Go ahead and Google search to learn more about this format. And if you do use OME-TIFF, again, there are a couple of ways. I should admit that I am currently working on a project. I work at Carl Zeiss right now, and the project actually, part of that, we actually had to find a way to read OME-TIFF images, and that's why I plan on including that as part of this tutorial. So go ahead and install. I have to look at exactly what the documentation is. So let me go ahead and copy this from online. And to pip install, it is pip install appear dash hyphen OME-TIFF hyphen library. Yeah. So pip install this first. Okay. And then you can call this. And how do you call this? From appear. Now this is underscore, not hyphen. Okay. Okay, from here you can import IO. Okay, and this is how you can, and these are again, multi-dimensional. And by the way, OME-TIFF actually has, maybe I haven't, maybe I haven't included, oh, right there. Now, OME-TIFF again is a 5D image, and it also has an XML embedded inside, that has all the metadata. So you can read both at the same time by unpacking. I believe, let me just call this OME XML or something. And this is equal to io.read, yeah? And you can see underscore OME-TIFF right there. So this is exactly what I want to use. Read underscore OME-TIFF, and everything else this is images slash test underscore image. I also saved this image as OME-TIFF, by the way, using image.j. So OME.TIFF. And if I go to File Explorer, I should see all these files. I have testimage.ome.tiff, testimage.czi, testimage.jpg, and this is exactly what I'm doing right there. And now you can just do print pic to, actually let's print the shape first, yeah, before looking at this data. And let's go ahead and run this. And no such file or directory, Python files, images, test underscore, again, I did a mistake here. This should be ome.tiff. I keep doing the same mistake, ome.tiff with one F. Okay, third time again. So the dimensions here is 1, 1, 3, 5, 13, and 639. So as you can see, this is time series and number of dimensions and RGB here and X and Y. So the RGB actually jumped from the end to the middle right here. But again, now we know that we are actually reading this. And in fact, if I print pic2, let's see what happens when we print pic2. And this is our this is basically the numpy array that we are printing. And you can also print the OME, I think we called it OME XML, correct? OME XML. So let's go ahead and print both of those, and it prints the entire XML file here, as you can see. Okay, so these are various ways of handling images. And this is a very long video. This turned out to be a long video. I should have cut it down into various ways, but then reading images is one topic where, I personally thought everything comes into one umbrella here. Now, before ending this, again, this is already a long video, so let's extend this by 5 more minutes. So far, we looked at reading only one image, but what if you have a whole bunch? Like, for example, under test images in here, I have a folder called airplane, and within airplane, I have 3 images. What if I want to read all 3? What if I want to read all the subfolders and all of that? So for that, we will use something called glob. Again, it's called, you can pip install this again using pip install glob. And this came from Unix. In Unix system, glob command enables us to actually go look into subdirectories and extract the file names. So we'll get the file name. So the way we do that is, let's do import cv2. Let's use, my favorite is OpenCV all the time when I read images, right? And then pyplot from Matplotlib to look at images. Okay, so but again, be careful that cv2 uses BGR and not RGB. So let's import glob. Okay, it's glob, and again, as I mentioned, it finds all path names. Let's actually define something called my path. My path is under images, test underscore images, and within test images, let's just select one folder, airplane, AEROPLANE, and this is our path. And I just want to just look at every file in this path. I can do star.jpg or whatever, this is probably something that you're familiar with. Now, I just would like to go inside this path, and then look at every file. So for file in glob.glob and path. So what it's doing is, it's going into that path, and I created a variable called file. and it's going in there, and let's go ahead and print file and see what happens. Okay, when I run this, you should see that it actually went into each of this, through the files, and then it's just giving me test1.2 JPEG, test2, test3.jpg. Okay, we know that it's working fine. It's actually printing the files. Okay, but what do we want to do with these files? Okay, so now that we got the file name, we can just go and do our cv2.im read, right? I mean, we know how to read the files, and in this case, it would be just file. Okay, so we are actually going through each file within this path and then reading this file, and now you can just print, for example, A. Okay, so when I do this, when I run this, you would see that it's actually printing this for test3. It actually printed it for test2. So it's going through each and every one of these images and doing what we want it to do for each of these images. So this is one way of automating your image processing tasks. For example, if I want to do, we already used let's say C equals to CV2 dot, if you remember, we changed the color before, color space from BGR to RGB. So let's go ahead and do that. CV2, we defined CV2 dot color underscore BGR to RGB. Okay, that's too much to type. I hope I didn't make any mistake. We'll find that out any second. And now let's just go ahead and do CV2 dot IM show, and let's say color image, and our color image is C. Okay, and anytime we do cv2 dot im show, we know that we need to do cv2 dot weight uppercase K. We learned that the hard way. 0, and then cv2 dot destroy all windows. Okay, so let's go ahead and run this. What I'm expecting is for it to go through each file, open it, display it to us, and then move on to the next file. So here you see, actually this is interesting. So we looked at all of these three, right? So before we look at these, let's actually do cv2.im show the original image. So you can actually get a feel for, first let's look at that and then run this. Let's not print. Let's actually do cv2. Let's copy these lines and paste it. I should have done that first. IM show. Let's just do original image, and our original image is A. Okay, cv2.im show original image. Wait, and let's run only this part of the code, and you should see the original images. It's showing up on my other screen. So here is the original image. 1. You keep an eye. The background is white. The tail is blue. This is second image. The sky is blue. The color, the plane is blue, and the third image, the plane is red. Background is blue. And now we actually change the colors down here. So let's go ahead and comment this. Actually, let's just delete that part and run it. And now you see the tail is red, and the background, the sky color is changed, and then the color is changed over there. So you can see we are just performing some basic operations right here where we change the color space from BGR to RGB. But we can do practically any image processing task on each image, and this is the best way to automate. Instead of now IM show, if we did IM save, I could have saved all those images into a different directory with a different name. So this is the best way of automating image processing tasks. Obviously, converting the color space is pretty basic, but you can do pretty advanced things as long as you can read a whole bunch of files like this. So anyway, again, very long tutorial, but I hope you found this very useful. We went through reading images using multiple libraries, including Pillow, scikit-image, OpenCV, and we also actually used Matplotlib to open an image, but then we used Matplotlib to primarily look at images, to plot images on the screen here. We also looked at a couple of proprietary image or non-standard image formats, how to open them. And again, Google search is the most powerful. If you don't know something, just go there, search for it, and chances are you'll find a solution online. And that's exactly how I learn pretty much every day. So thank you very much. And in the next tutorial, let's start opening these images and doing some basic image processing. Thank you.